This video should not be used for marketing purposes. It is meant only for trainers and partners who are interested in learning on how to make a marketing presentation. Decision making, dealing with uncertainties and risk, going beyond common sense, experience, judgment, intuition, gut feel, etc., which is what we normally use to make decisions. So how do we make decisions? Most of us rely on some form of interpretation of data and information based on traits such as intuition, experience, perception, judgment, gut feeling. And by intuition we mean precognition, divine inspiration, priming, etc. However, behind all these traits is probability, a mental assessment of the likelihood of an event happening. When we interpret data, we give credence to various probabilities, even if they are qualitative. Sadly, this probability is colored by our experience or our limited exposure rather than reality. So let's see if this is true. Let me try a simple example. If every week lottery winners are paraded on TV and we only see the winners, we tend to believe that we too have a chance of winning and we would probably buy a ticket. Now what if all the millions who did not win are also paraded along with the few winners? We would probably not buy a ticket because we see so many losers. Let's take another example. 10 lottery tickets priced at $1 each were offered to students. The price, the winner would get $20. Of the 30 students who participated, 24 purchased a ticket. That's 80%. Then another group were told that Big Joe, a student, had already purchased 9 tickets and they could buy the last available ticket. Only 8 students opted to buy the last ticket. That's 27% refused, because they all felt that Big Joe was almost certain to win. However, note that your chances of winning under both scenarios was 1 in 10. Yet in one case 80% purchased a ticket, while in the other only 27% did. This is how framing of the problem impacts our decisions. In a well-known research study, people were asked to estimate the number of deaths in the US each year from causes such as tornadoes, fireworks, asthma, and drowning. And the average response was something like this. But the actual numbers were totally different. With tornadoes and fireworks, they overestimated significantly, whereas with asthma and drowning, they underestimate, because deaths due to tornadoes and fireworks get reported. But deaths due to asthma and drowning, being so common, are never reported. So we don't get an exposure to it, so we form our own opinions. We're in trouble again. Well, let's try a corporate scenario. When we have multiple probabilities, let's see if common sense can help us. A company is trying to get some raw materials from one of 3 nations in Africa: Angola, Congo, and Liberia. Intelligence reports suggest that political instabilities and ethnic tensions could disrupt contract fulfillment. The question is, with this basic information, can we make a common sense decision? No. Even to use common sense, we need some data on risks and exposure. If so, what type of data are we seeking? Certainly, we would like to know something about the likelihood of these events happening. This is what we call event probabilities. So let's put some numbers. Angola, there's a 25% chance of riots. Congo, there's a 30% chance of a coup. Liberia, there's a 35% chance of a new government. Can we now make a common sense decision? Maybe, but a bit risky, because we really don't know the impact of these events. So let's put some numbers on that too. Congo, which has a 25% probability of riots, might have an impact, say a 22% probability that we might still get 95% of the contract, 49% probability that we might only get 71% of the contract, and 29% probability that we might only get 43% of the contract. Angola and Liberia, we have similar data. Ladies and gentlemen, 21 data points now. Can we now make a common sense decision? Oops, too much information. So you see where we are struggling. For example, with regard to multiple criteria. You and your spouse have retired and you're planning on moving to a more appropriate city in the US. How would you go about living? Well, you might think about crime, pollution, hospitals since you're getting a little old, price of housing, etc. So let's put down some criteria. Here I have 11 criteria. Let's get data for 7 cities in the USA. These are factual data from the internet. Now can you decide where you would like to live? No, ladies and gentlemen, we're facing information overload. The problem is not with the information. The problem is that we don't have a methodology to handle this. Company buying detergents might have the same problem. There are a multitude of criteria and plenty of information. We need to try to figure out how to make a decision. One last problem of common sense. Here are 3 people. Roger, who is married, is looking at Mary. Mary is looking at David, who is unmarried. Looking at this picture, is a married person looking at an unmarried person? A, yes, B, no, or C, need more information. I suggest you pause the video now and answer the question whether it's A, B, or C, and then proceed to see the rest of the story. When we present this to students and senior management, almost 99% of the time they say we need more information. We need to know if Mary is married or unmarried. But the truth is, it doesn't matter. Let's simulate this. If Mary is married, a married person is looking at an unmarried person. If Mary is unmarried, again a married person is looking at an unmarried. So we did not need more information, even though common sense told us we needed information. With all the previous examples, our common sense decisions were not very convincing. We agree that anyone can make a decision and live with the consequences. But it would be very difficult to defend such a decision in a corporate setting. You see, common sense is necessary, but not sufficient. Your only hope is to incorporate analytics to reinforce your common sense. Professor Dan Ariely explained why we have so much trouble when making decisions. Let's take a look at a couple of his videos. Please check the videos at these links. So why are we consistently making suboptimal decisions? Some of the common pitfalls are really our desire to be informed. In other words, seeking more information. The tendency to avoid complexity. Shifting comparisons. Ghost offerings. Default options. Perception. And even priming. Let's consider somebody buying a camera, let's say in 1950, when we didn't have the internet. One would simply look at some glossy magazines, picture a few cameras, talk to people who have some cameras, even try out a few, decide on 1 or 2, and then go to a shop in the city that may have 10 cameras, and one would buy a camera. But today, we Google. And what do we see? 50 reviews on cameras, which is information overload. And then we go on Amazon.com or some other similar website, and what do we see? Hundreds of cameras, choice overload. Thanks to the internet, now it is possible to be extremely well informed and yet be completely wrong at the same time. Even in corporate America, executives face the same dilemma: information overload, manpower distribution, budget, sales, transport, cash flow, sales price, all these variables. They are struggling to make better decisions. Let's try to understand what we mean by solving a problem. Solving a problem is a three-part operation. First is problem analysis. This is to identify the options and solutions. Then it's the time to make a decision. That is to select one that we would act upon. And finally, we implement it. This discussion is limited to decision making, because problem solving is not decision making. Problem solving is unique to the problem, to the domain expert. Decision making is unique to the person. It's human judgment. To illustrate this, let's consider somebody having a car and driving out after work, and the red light comes to say service engine. He goes to his neighborhood mechanic, and the mechanic runs a diagnostic. Sir, you've got a gear train problem. So you naturally ask, what do I do? Well, I can try to repair it, but I'm not quite sure about shelf life. We can put a refurbished unit, or we can even put a brand new unit. Cost a few dollars extra. And as you ponder, he says, well, your car is knocking a few years, you may want to sell it. You see, the domain expert, the mechanic, he gave you four options: repair, replace with a refurbished unit, a brand new unit, or selling the car. The mechanic does not know your personal circumstances. You've been out of a job for 2 years, or your daughter needs a car for local running, or your mother-in-law needs a car, or you have some financial issues. The mechanic cannot make a decision for you. He can certainly solve your problem, but you must make the decision. The president of a nation or a country does not solve problems. He or she makes decisions. So why do we have to make decisions? It's an interesting question. It sounds so obvious, but the answer is a little trickier. The only reason we have to make a decision is because something called change. If nothing changes, we don't have to make any decisions. Change happens, or we initiate change. The sun comes up, the sun goes down. The waves come, the waves go. That's what change happens. But we can also initiate change. We can get married, hire employees, buy cars. This is changing. We respond to change because we want to be happy. That's the only reason. Even a decision not to respond is driven by our desire to be happy, or self-preservation, or seeking a positive outcome. With change comes conflict. We don't like something changing subtly. It causes us a situation of having to rethink. These conflicts could be a result of definitions, interests, values, emotions, environment, our roles, our perception, our knowledge, or even the timing, right? But there are conflicts. And with conflicts come along problems and opportunities. For example, imagine you get a cup of tea every morning with milk and sugar. One day, the sugar doesn't come. You have now a choice. It's a problem because you don't feel like drinking. It's an opportunity because you could probably give up on sugar. Well, there's an anecdotal story about a shoe manufacturing company sending two salesmen to a country. One goes east, the other goes west. Country in a developing nation. 2 weeks later, one sends an email saying, I don't know what I'm doing here. These guys don't wear shoes. How am I to sell shoes? The other guy sends an email saying, phenomenal opportunity. Nobody has tapped this market. Let's build a shoe factory here. One saw a problem, the other saw an opportunity. irrespective of whether it's a problem or an opportunity. At the end of the day, we have to find a solution. And if there are multiple solutions, you have to decide on one to improve. Really a simple chain of change, demanding decisions, which we make to be happy. At the end of the day, they are inseparable because we have an inherent yearning to be happy. This is our objective. In fact, long before me, Charles Darwin said something very similar. It is not the strongest of the species that survive or the most intelligent, but the one most responsive to change. Let's look at multi-criteria decision making. When we deal with decision making, the simplistic process is to start with an objective, identify some candidates, these are options or likely solutions, and then evaluate these and make a decision. I urge you to consider criteria in your decision making process. Criteria are factors that influence the decision. Now that you have criteria and candidates, you need a process. So we will look at this down the road. When you deal with criteria, there are two very important elements that we need to think of. First is selecting the most relevant criteria, and then determining the significance of each criteria. Beware, too many criteria can be counterproductive. Let's look at a method that is known as the matrix method for dealing with multi-criteria decision making. You are the fleet manager of a rental car company and you have to buy 200 cars. Start with some criteria. In this case, let's just use three simple criteria: reliability, price, and miles per gallon. We assign some weights for whatever way we can, and we like reliability more, so we put 48%. And then we select some candidate vehicles: Honda, Toyota, Nissan, and Mitsubishi. The next thing we do is we simply look at the data and we try to assign some points. So we have the weights here and the points here. And we do the same for the other criteria. And finally, we multiply the points by the weights and we declare the winner, in this case being Honda. So let's say I go home tonight and I have to make a presentation tomorrow morning, and then my wife had invited her brother for dinner. And when he comes over, I talk to him about this whole episode, and he reminds me and says, "Hey, by the way, don't forget my uncle owns a Mitsubishi dealership. Is there some way you can help the family?" So what do? I quietly change the 20% weight here to a 50%. And now Mitsubishi Galant is a winner. So as most of us know, with the power of Excel these days, we can fiddle with numbers to get the desired result. So we certainly need a better method. Our approach to multi-criteria decision making is based on a 7-step approach. Let me lay it down. First, we must clearly define the objective, and this is easier said than done. Then we identify all relevant criteria. Step 3 is to conduct what is known as criteria segregation. This is where we extract the most important criteria. Then we identify all available candidates and options. We gather information on these candidates as they pertain to the criteria and form a judgment table. Then we assign weights to our obligatory criteria and finally rank our candidates. If you see, I have the letters AHP, which stands for Analytic Hierarchy Process, assigned to steps 3, 6, and 7. So what is AHP? Is AHP reliable? Who is using AHP? Well, just Google it and you will see a pretty comprehensive explanation. At a recent international conference on AHP, 19 countries presented papers. Over 90 papers were presented. In fact, a Google search will show places such as Taiwan, China, Japan, USA, even the military base closure study using AHP, South Korea, Finland, India. All these countries use HP for many problems that they have to address. The best way to explain the HP process is through a simple example. Imagine you're at an airport lounge waiting for a flight. While watching the TV, pictures of two beautiful women are presented to you, and you're asked to distribute 100 points among these ladies to reflect their beauty. Your personal choice. You might say 60, 40, 30, 70, whatever the number is. Probably it's not very difficult. A minute later, 4 pictures pop up, and once again you're asked to distribute 100 points among these ladies to reflect their beauty. Well, it got a little more difficult, but still manageable. A minute later, 7 pictures pop up, and this time you simply decide to give up because it requires a lot more attention. Would you say that the pair was the easiest to handle? And would you also agree that as the number of contestants increased, it became increasingly more difficult to make a reliable judgment? Yes, 2 was the easiest. Imagine a recruiting situation. Your president informs you that you have been promoted to senior vice president, but you need to find somebody to replace you. And you are entrusted with this responsibility. So you start with many criteria. Here I show 37 criteria. And then you select some of the relevant criteria. So let's say you pick 7 criteria. I just put them at random. And then on top of that, you have 7 candidates. Ladies and gentlemen, in the previous example, you had only one single criterion: facial beauty. You didn't see the body, the walk, the sense of humor, the education, nothing, the bathing suits, nothing. You just saw one facial beauty criterion and 7 candidates, and you gave up. Just imagine dealing with 7 criteria and 7 candidates, not to mention 3 decision makers. Ladies and gentlemen, this is the 3-dimensional problem now. In fact, Peter Drucker said 2/3 of your hiring decisions will be suboptimal within 1 year. And the Society of Human Resource Management, SHRM, did a survey and found out that the hiring decisions are made in the first 5.3 minutes of an interview. We're not doing a very good job when it comes to decisions. Let's try to explain the AHP technique so that we can get a better handle on it. When comparing a pair of elements, we express the dominance of one over the other using a scale of equal, weak, moderate, strong, absolute. Here we are interested in the dominance. That means the importance, the preference, or the likelihood. And remember, we are interested in the difference, which is natural for humans. To help you understand, let's imagine I ask you, would you like A, cake, or B, fruit salad? The first question is simply, which one do you like more? So we would say, okay, I like cake, let's say A. Then I ask you, how much, which is the degree of preference. So what we have now done is simply expressed our preference with 2 questions. Which one and how much? AHP itself is a very complicated process. It's based on eigenmathematics, but you don't have to do this because we have developed our own software to help you navigate this easily. Hopefully you will gain more confidence as we go along. As we search for the optimum decision, we have to deal with 2 parts. First, the quality of the decision, and then the implementation. The quality of the decision is a function of the data and the information, the context information, the criterion candidates, the solution technique used, and the expertise of the decision maker. Now, the outcome, on the other hand, is tied to the implementation as well. Because you can have a high quality decision poorly implemented, and we don't want to mix the 2. So do not judge the quality of a decision by the outcome, because they are totally. When we deal with uncertainties, we need to consider the following. 1, the likelihood of the event occurring. We refer to this as event probability. 2, the likely consequences associated with that event and the magnitude. We refer to this as impact probability. And finally, the level of tolerance. The best way to deal with single criteria. Your company requires the metal MZ and your only source is from Africa. However, due to political instabilities, there is a potential threat to supplies, basically contract fulfillment. For this analysis, let us ignore cost issues and only focus ourselves on getting the metal. If you recall, earlier we discussed probabilities and I referred to event probabilities and impact probabilities. Here's an example. On the left hand side we have event probabilities and on the right hand side we have the impact probabilities or the consequences. So there's a 20% probability that there would be riots in Congo. Associated with that, there's a 22% chance we would get a 95% of our contract fulfilled, 49% probability that we would only get 71% of the contract, and the balance 29%, the estimate is about 43% of the contract. Similarly, for the other events, we have associated probability. Sometimes people ask me, how do you get all these numbers? Where do they come from? Well, I must admit, they are best guesses or estimates. Now, sometimes this information comes from reliable sources based on various scenarios, but it doesn't matter where the numbers come from or how accurate the numbers are. Because think about the scenario if you didn't have this technique, you had to rely on common sense. Then you've got to play in your mind with all these event probabilities. Don't you think it is better to use a structured analytical method, even if the numbers are not exact? Because with our decision zone maps, we can actually look at the sensitivity and the error levels of our estimate. Let's look at our decision zone map. Here we have 3 scroll bars now. The red, which reflects the probability of Congo riots. The blue, which reflects the probability of Sierra Leone's coup. And up here, we have a brown scroll bar that reflects the probability of Angola's new governor, which is at 35%. Under this scenario, the recommendation is to operate from Congo. Now here we have 3 zones, and the center point is known as the triple point. And observe, we have the triple point fixed with Angola. And if I change that, the triple point moves. As before, we are now in the Congo zone, and by changing the probabilities, we can suddenly move to Sierra Leone. Or moving upwards, we go to Angola. And if we have some doubts now, we can go back to Congo. So you see, management can now sit at a table and discuss the exposure levels. And once again, this horizontal distance from the diamond to this zone demarcation line, horizontally, or from the diamond to this demarcation line, tells us how much latitude we have with our assumptions. There is absolutely no doubt this is truly a very powerful technique. Now, in this case, we only discussed procurement. This could be 3 retail sites, or 3 international projects, or 3 pieces of equipment, or 3 candidates that you wish to hire, and you have certain concern. When we make a decision, there are 2 areas of concern. First is the decision maker and the buyers. If the decision maker doesn't like mauve colored ice, there's nothing you can do about that bias. That's his bias, but he's the decision maker. Likewise, changing environment creates uncertainty and risk. So how do we handle this? The best way to explain this is with an example. Imagine a hotel chain is considering hiring a business development manager. They settle on 6 criteria, and one being availability within 2 weeks. They identify 4 candidates, and they run a model such as XpertUS multi-criteria decision-making software that we offer. that we have now completed the evaluation and we have our graph. The software indicates that Mary is the preferred candidate. So I go to my boss and I say, hey, I think we need to hire Mary. And the boss says, hold it. If you're willing to wait a little longer, should we still hire Mary? And I would scratch my head. But with the software, we simply press one button and we see a very important graph. And this is where I would like to draw your attention. This is the original evaluation that you just saw narrowed down. Mary is once again with 32% here. Now, since we had 6 criteria, we have 6 additional bands. 1, 2, 3, 4, 5, 6. But these bands are for 5 criteria. This one is for 6, but the others are for 5 criteria. We call it the N-1 analysis. This band here shows the result if availability is not considered. You can see it's minus availability. If availability is not an issue, we should hire Jane. Now then the boss would ask me, hey, if you're willing to pay whatever it takes, who should we consider? Once again, we look at the picture and here we see if salary is not an issue, Sue is a much better strength. So with this type of model, we can look to see if we have over-constrained our decision by our preferences and biases. Okay. To recap, given the same set of data and information, different people will make different decisions because real-world decisions are multidimensional. Multiple criteria, multiple candidates, and multiple stakeholders and decision makers. So set a clear objective, segregate your criteria, make the decision, and then we have to validate. Knowledge is power. True? Well, not really. Information when acquired is knowledge. Knowledge when utilized is power. We invite you to try the free skill test and our workshops and our books at www.XpertUS.com.